Hi, all. I'm Dhanalakshmi. I am working as an assistant professor from National Engineering College from Triple department. Today we are learn the topic of current shopping. So current shopping means current is forced to zero before its natural zero point. Normally the AC current naturally becomes zero at every cycle, but in current shopping, the breaker cuts the current suddenly before it reaches the zero. So it typically occurs when switching off low inductive current, like transformer magnetizing current. In some situations, energy is stored in the magnetic field L at the moment of current shopping is transferred to the system capacitor, resulting in high voltage transfer. In current shopping, the L is transferred to capacitor at a high voltage transient condition. Because this is the voltage, the L is transferred to C. Uh, the energy stored in the magnetic field is equal to half L I square. If it is the instantaneous value of current which is interrupted, this will appear in the form of the half Li square is appeared in the form of half CV square. Then half Li squared is equal to half CV squared. So finally we got V is equal to I into root of S by C. So the effect of current shopping is that high over voltage, damage to insulation, stress on equipment, may cause resetting voltage. So the current shopping is mainly after air circuit breaker. Because the air circuit breaker has um, low current, that is the inductive field. This is the uh, waveform of current shocking. So this is the arc voltage. At suddenly, the transient voltage, it will increase the some transient condition. It will increase the voltage level. After some condition, it will recover. So at a zero initial condition, it will recover. So this is the first current shock, and this is final current zero. This is zero crossing point. This is arc voltage. This is restriking voltage. This is recovery voltage. So if the value of this value of V is more than because the arc is formed in between the contact, the voltage will appear. So this voltage is more than the withstanding capacity of the gap within the contact. The arc appears again since punching force is uh, if the since punching force is more, the current is again chopped. So this phenomena continues until the value of V is less than the withstanding capacity of the gap within the contact. and it also reduced by using resistance switching, reduced using resistance switching and surge arrested. So, and proper circuit breaker design and also reduce this current shopping. So the current shopping means, so this is the premature introduction of current before its natural zero causing high over voltage in inductive circuit is called current shopping. So how to reduce the current shopping? This voltage is less than the withstanding capacity of the gap between the contact, or otherwise the voltage is greater than the withstanding capacity of the voltage. The arc appear again. The current shocked again and again. So this is the current shocking. And uh, now we see one. Now we see one problem, current shocking problem. So a circuit breaker interrupts the magnetizing current of 100 MVA transformer at 220 kV. The magnetizing current of the transformer is 5% of the full load current. Determine the maximum voltage. Determine the maximum voltage which may appear across the gap of the breaker. Then the magnetizing current is interrupted. 53% of its peak value. The stray capacitance is the 2500 millifarad and the inductance is the 30 Henry. Now the formula V is equal to I into root of L by C. The voltage is less than the withstanding capacity of the arc. It will the current shock will less. So finding the voltage. So first we find the full load. First we have to find the height. So the full load current of transformer is by root 3 into V, because S is equal to root 3 into VA. So now the S is 100 MVA. So 10 power 6 by root 3 into the voltage is 220 kV. Now we got 262.43 ampere. So the here the magnetizing current. So the magnetizing current magnetizing current is 5% of full load current. Here 5% of full load current is 262.43. Finally, we got 13.1215 amps, and determine the maximum voltage which appear across the gap of the breaker. Then the magnetizing current is interrupted at 53% of peak value. So for that reason, current shopping occurs at the current shopping occurs at 53% of peak value. So this is the 13.125 is the RMS value. First we have to convert our peak value. So root 2 into 13.1215. Finally we got 9.84 amps. Then V is equal to I into root of L by C. So the I is 9.82. The inductance is 30 Henry. So the capacitance is 2500 millifarad. Finally, we got finally we got the voltage is 107,682. Here, this voltage is uh, uh, less than the gap between the contact of the voltage. So the current dropping is 0.